All right. Hello, everyone. So the purpose of this video is just to get some practice drawing this normal distribution, which is something we'll do kind of a lot throughout the semester because, as we'll see later, this normal distribution does get used for more formal statistical analysis of some types of data. And so we're going to draw this distribution using this 68, 95, 99 rule. And so we'll go ahead and define what the rule is, and then we will use it to draw this distribution of newborn baby weights in the US. And so the rule just says that about 68% of all observations for a normally distributed variable fall within one standard deviation of the mean. All right, so this will make more sense when we do the picture, but the 95 and 99 part of the rule just say that about 95%, and I'm going to use these little double quotes to indicate that all these words are the same. So about 95% of all observations for a normally distributed variable fall within 2 standard deviations of the mean. And about 99% of all observations for a normally distributed variable fall within 3 standard deviations of the mean. Okay, so what does that really mean? Well, it's easier to see visually, like most things in statistics are, much easier to see with a picture or a graph. And so we're gonna use this baby weight example. And so we know that in the US, newborn baby weights are normally distributed, at least approximately, with a mean of 7. So there's our little mu symbol and a standard deviation of 2. And so let's draw this distribution using this rule as an approximate guide. And so I'm first just going to draw the curve. Oh, why am I so bad? Okay. Okay, it's not the best. It's a little bit not symmetric, but this is going to be my normal distribution curve. I'm going to center it at 7. And then I see that my standard deviation is 2. And so our rule says that about 68% of all of the observations, which means 68% of all of the baby weights, should fall within a standard deviation. So if a standard deviation is 2 pounds, then I'm going to try my darndest to go out 1 standard deviation on either side. So I'm adding a standard deviation and I'm subtracting 1. If I did my drawing correctly, then our rule says that about 68% of that area should be shaded according to this rule and if I did my drawing correctly. And so that's kind of your guide for how far out the tick marks go. Like if I had done a 9 here and a 5 here, so you don't have to copy that if you don't want to muck up your drawing. Then I would be shading that tiny little strip, and that's obviously not 68% of the area that's under this curve. That's way less. So that's bad. Similarly, if I did like the first tick mark way out here, then the shaded area would be way more than 68% of the area under the curve. So this is just meant as a rough guide to kind of help us get an approximate distribution. Okay. And then when I go 2 standard deviations out, so I'm going to make my next tick mark be 11. So that's mu plus 2 standard deviations. And then on this side, it's going to be 3. Then that means that that area, so if you shaded between 11 and 3, that should be 95%. And so that's what our rule is telling us. Then if you go out even further and you go out one more, so I'm going to mark 13 and 1. Then between those two numbers, if you shaded all that area, that should be 99% of the area. What this means, at least according to our rule and our approximate normal distribution, it means 99% of all the babies that are born in the US are between 1 pound and 13 pounds. It means 95% of all the babies that are born in the US are between 3 pounds and 11 pounds. And it means 68%, or about 2/3 of all the babies that are born in the US are between 5 pounds and 9 pounds. So we're using this rule to kind of give us a guide for drawing this distribution. Okay, we'll save this for next time, and just to kind of write a little bit that we will be covering this stuff in class when we meet. Okay, so as always, let me know if you have any questions.